A DynamoDB local secondary index is an index that has the same partition key as the base table but a different sort key. Now this is referred to as a local index because the index remains on the same partition as that of the base table and is local to that. In this video, let's learn more about local secondary index, how to create them, and how to query using the index from the AWS console and also using a .NET application. Using a local secondary index provides faster data access, especially when you need to sort the data based on a different sort key on the same partition key as that of your base table. Hello everyone, welcome back to this YouTube channel. My name is Rahul, and if you're new here, I make videos on .NET, Cloud, and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Without much delay, let's get straight into learning more about local secondary index in DynamoDB. Some applications might need to query data only using the base table's primary keys. However, there might be scenarios where you need to access the data based on different keys. This is where index comes into play. We saw how the global secondary index helps us to create a completely different partition and sort key and use that to our advantage when building applications. Now the local secondary index is more appropriate when the partition key that you're using is exactly same as that of the base table. The only thing you need different is the sort key. So in this case, we would be creating a local secondary index. Now a local secondary index has certain conditions. The partition key must be the same as that of the base table. The sort key consists of exactly one scalar attribute. So this needs to be a scalar attribute that you can use as the sort key. The sort key of the base table is projected into the index where it acts as a non-key attribute. Now this is something that happens automatically. So let's see how we can create a local secondary index and use that to our advantage. If you navigate to the AWS console, you can create a local secondary index from here while creating a new table. Now one thing to note is a local secondary index cannot be created after a table has been already created. So you cannot add one to an existing table. So in this case, let's create a completely new table, and while we are creating the table, let's also create the local secondary index. So in this case, let's specify the table name as weather forecast table. Let's specify the same partition key as we had for the other table, which is the city name, and also date. That is going to be the partition key and the sort key of the base table. Now to create the local secondary index, let's click Customize Settings and scroll down, and let's select under the indexes the Create Local Index. Now note this can be done only when creating the table. So let's select that. Now since the partition key has to be exactly same as that of the base table, this only prompts us to enter the sort key. So in this case, let's specify the temperature C as the sort key. So this also names this as temperature C index. Now you can choose the attributes to be projected from the base table onto this index. Now we have three options, and by default it's selected to all, which means all of the table's attributes will be projected into this index as well. Now the other options you can specify is only keys, which means only the primary keys are projected into the index. So that will be the additional date time in our case, which will be projected into this index. Or you can also specify specific attributes to be projected into this item so that you only use less storage and overhead to maintain this index. Now it is highly recommended to use the include if you only need a certain properties on the index. Now if you don't need any of the additional properties, you can also choose only keys. So in this case, let's specify only keys and click Create the Index. Now this is going to create a new index and specify it. Now we can also create a new index if we want. So let's go to Create Local Index. Let's use the temperature C again. Let's say dash include. And in this case, we can also include an extra attribute, let's say the summary attribute. And let's say create index. So in this case, we have two indexes already created. So let's create the table and also create the index at the same time. So once the table is created, we can start inserting data into this and see how the index is getting populated and use it from our queries. The table is successfully created and it shows the active status. So if you click and navigate into that, you can go into the indexes and see the existing index on this particular table. Now you can see here that we don't have any global secondary index, but we have two local secondary indexes. And also we can only create a global secondary index on an existing table, which we saw earlier in the previous video. So let's navigate to Rider and add some data into this particular table. So I have an existing solution already opened here, which is a default ASP.NET Core API solution with the weather forecast data and the weather forecast controller. I started using this in my 5 ways to query DynamoDB video, from which I have been building different querying and accessing patterns on DynamoDB. You can view that video, which will be linked here. Now this class has different methods based on the querying patterns and features that DynamoDB supports. You can go through this if you want to see the different scenarios that you could use in your application. The associated videos will also be linked in the descriptions below. So let's search for the method post, and here we have the weather forecast post. So let's copy this and let's create a new post method for our weather forecast table. So in this case, let's also rename this route. So let's specify this as post weather forecast table. And let's add LSI so that we remember this was for LSI. Let's make sure to keep that in double quotes so that the route will be specific to that. Now in this case, let's name this as post weather forecast LSI. And we need to create a new class as well. So let's come in here and let's create a new class. Let's call this as weather forecast table so that it matches the convention of the table name. Let's add 2 properties from the weather forecast, which will be the city name and the date. Let's also choose temperature C and up until the summary properties. So let's copy all those properties and let's paste it in here. Now let's remove the temperature F because we don't need that. Now in this particular case, we have all the properties that's required by the table. So let's come back to the controller. Let's replace this weather forecast with the weather forecast table item. So let's specify that and let's run this application. Now we can start posting data into our new table so that we can use it from the index as well. So let's scroll down, go to the post method, which is with the weather forecast table LSI. Let's specify try it out. Let's choose the city name as Brisbane and let's specify the temperature as 10, which is what the current temperature is. So let's specify the summary as cold and let's click execute. Now in this case, if I scroll down, I can see there is an exception which says one or more parameter values were invalid because the index key temperature C expected an S, but it is actually an N. So I guess when I selected the attribute for the index, I accidentally selected this as a string. But that is okay because I'll just fix the code to make that as a string attribute as well. But note that when you create the sort key to choose the appropriate type based on the property you will be projecting into that. So if I navigate back into the code, let's stop this. And instead of an int string, let's make this as a string temperature for now. So let's run this again and let's execute this method again. So let's come back to the Swagger API. Let's fix this to be a string temperature and let's click execute again. Now if you scroll down, you can see this time it is successfully inserted. So if you navigate back to the table, so let's go into the explore table items and let's say run the query, we can see the new item that is inserted. Now if you want, you can come back to the API and insert a few more for other cities. So let's specify Mumbai, let's specify the temperature as 30 and let's say it's hot and click execute. Now let's also specify Sydney and in this case let's specify 8 and let's specify it's very cold there. And let's click execute again. Now if I navigate back to the items and do a scan on this particular table, so let's specify weather forecast table and click run, you can see that 3 data that is coming into this particular table. Now instead of the weather forecast table, you can also choose the index to query this data on. So this shows the 2 index that we have already created in this particular table. So let's select that. So let's specify the index and click run. Now in this case, this is selected to be all attributes, which means it shows all the attributes of the item. So if you want to specify projected attributes, this will only show the projected attributes for this specific index. Now in this case, with the temperature C index, we only exported the keys. So this is why it is showing the city name, the date, which is the key on the base table, and also the new key on this index. Now if I was to choose the other index, which includes the summary and run, you can see that also shows the summary information for that particular index. Now, note that when using local secondary index, since this is accessing the same local partition, you have the option to project all the attributes as well. So even if I was to choose the temperature C index and specify all attributes, let's click run, this still shows all the attributes on the table. This is using a feature called Fetches in DynamoDB. Now what happens is DynamoDB automatically fetches these attributes from the base table, but at a greater latency and throughput cost. So when we are making a request on the index, it first gets all the attributes from the index, and for any missing attributes, it makes an additional call to the base table using the keys that it has to fetch the additional attributes. So if you were to choose the projected attributes, it doesn't need to make any additional calls because it only projects the additional attributes. However, it makes the fetches if you choose all attributes or specific attributes which are not included as part of the original secondary index. So if you were to specify an additional property in here, that would also mean that it has to make an additional fetch request. So from an application perspective, even though it looks like it is retrieving all the data exactly as same, this does have additional cost and latency involved. So make sure you choose the appropriate attributes to be projected onto the index in the first place. Now that we've seen how to make queries from the AWS console, let's see how we can use the local secondary index from a .NET application. So let's switch back to Rider. Let's stop this and let's come into our weather forecast controller and scroll down to the method where we use the GSI query. Now the querying is exactly the same as we query a global secondary index. So let me copy all of this and let's paste this in here and let's walk through the method. So let's rename this to be LSI and let's also rename this to be LSI. Now in this case, we are creating a query request and using it with the DynamoDB client. Now once you have specified the table name, so in this case, this is going to be the weather forecast table instead of the weather forecast. We can specify the index name. So let's navigate back to the AWS console. Let's go into the weather forecast table. Let's go under indexes and let's copy the index name. So let's specify the temperature C index and let's paste that inside the index name in here. Now we can specify the key condition expression, which in our case is going to be the same as the partition key of the base table, which is the city name. So let's replace this to be city name. So let's specify city name and let's pass the city name as the string. So let's specify colon city name as the attribute value. Now in this case, since we don't have any reserved keywords or parameterized attribute names, we can remove the expression attribute names. So let's remove that. Let's specify the city name in this particular case and pass the city name as the attribute value. So let's simply name the city name, which is going to come from the method. So instead of the date time, let's specify string city name. Now once that is specified, we can create a new item, which is the weather forecast LSI item. So let's create a new class to project this result into. So let's specify this as weather forecast LSI item. And let's copy the properties from the GSI item. So in this case, we have the city name, the date, and also the temperature C. So it's exactly the same properties. So let's simply duplicate this again. Now, once I have the LSI item, I need to return back as the LSI item. So let me fix this as well to return the LSI item. I have the T capital, so let me fix that by renaming this. So let's say apply renaming, and then that gets fixed here as well. We can execute this to see this in action. So let's put a breakpoint in here and step through the code while this is executing. So let's refresh this. Let's scroll down and let's choose the LSI query method that we just inserted. So let's specify a city name. In this case, let's specify Brisbane and let's click execute. Now this is going to hit the query. So it's going to create the query request, specify the table name as a weather forecast table, and then specify the index name and also the condition expressions on that. So let's press F5 and this is going to return one data for this particular city because we only entered one data. Now you can see the temperature C is 10 in this particular case. Now if I was to go to the put method, so let's go back to the put method where we created a new item and let's say try it out and let's specify a new value. So let's specify Brisbane. So instead of 711, let's specify this as 710 and let's specify the temperature as 15 present as pleasant and click execute. Now this is going to add a new record. So if I was to come back to the LSI query and execute this again, and this is going to return 2 items. So you can see there is one item which the temperature C as 10 and the other item with temperature C as 15. On this local secondary index, you can also provide additional conditions on the sort key and get back the temperatures which is specific to a value or also greater than, less than, etc. We saw this in my querying video in DynamoDB. So I highly recommend checking that out to see the different querying patterns that you can apply on the partition and the sort key. To fetch additional attributes like we saw in the AWS console, we can also use projection expressions when using .NET applications. Let's add in a new property to the weather forecast LSI item. So let's navigate to this and let's specify the property summary. So let's specify property, string, and let's specify summary. Now for consistency, let's keep this as well string because our item type is string inside the table. So let's add in the summary and let's run this to see what is happening. So once I run this application, let's navigate to the Swagger, execute this again. And in this case, the summary is returned as null. This is because I'm using an index for this particular one. This is the temperature C index, which doesn't have the summary property projected into this. So when you're using the DynamoDB client, by default, it does not do the fetches which the AWS console automatically does for you. You can do this by using the projection expressions. Now, if you want to learn more about projection expressions, I highly recommend checking out my video which is linked here and also in the descriptions below. But as an example, let's come here and add the projection expressions attributes and let's explicitly specify the properties that we need to be projected. So if we come back into the item, we need the city name, the date, temperature C, and summary. So let's specify that. So let's specify city name, temperature C, the date. So in this case, we need to use the hash date because the date is a reserved keyword. And let's also specify the summary. Now, since we have specified the hash date, we need to pass in the expression attribute names. So let's specify the expression attribute names, which is a new dictionary. And let's create a map for this hash date. So let's specify hash date and map it to the appropriate name, which is going to be date. So let's wrap this in braces to make this as a dictionary key value item. Now, once we have specified the specific projection expressions, let's run this application again. Let's come back to our Swagger UI and click execute on Brisbane for this LSI query. And you can see that this is now starting to populate the summary. Now it shows cold, pleasant, and the summary cold for the 3 items, even though we did not project this into the actual index. Now I have used projection expressions, which is now making additional calls at the DynamoDB level to fetch the attributes from the base table. You could also have achieved this without the projection expressions, but simply by using the other index. So if I was to comment out that and switch back into the other index, which is named the temperature C index-include, so let's specify that and run this. And if we execute the same query, we are going to get the same result back. So you can see that the summary is populated even though we did not use projection expressions. But in this case, the index actually had the attribute because of which we didn't need to do projection expressions. And also it doesn't have to do additional fetches from the base table. So from an API perspective, even when using projection expressions, it looks very similar to using an index which has the attribute already projected. This does incur additional cost and latency when using DynamoDB. So I highly recommend using the appropriate attributes that you will be needing on the query on the index as well, and to avoid using the fetches feature. But if you're using the fetches very rarely from your application, then that should be fine as well. I hope this helps you to understand more about local secondary index in DynamoDB, how to create them, and how to use them from a .NET application. We also saw how to use this from an AWS console, and we also saw how to get additional attributes which are not projected by using the fetches functionality in DynamoDB. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.